Hello dear students, a warm welcome to all of you. In this session, we will be dealing with the topic coordinate geometry. Let's have an overview about the key contents of this chapter. Distance formula, section formula, midpoint formula, area of triangle formula, collinearity condition, centroid of a triangle. Beginning with distance formula, let there be a point P on a plane with coordinates x1 and y1, and let Q be another point with coordinates x2 and y2. Using distance formula, we can find the distance between P and Q given by the equation PQ is equal to root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Now let's say we have to find the distance of a point from the origin, and let the point be B and let the coordinates of B be x, y. Now we know that the coordinates of the origin is 0, 0. Now to find the distance between the origin and B, we use the equation root of x square plus y square. We know 0, 0, so we can simplify and arrive at this equation if we apply all the coordinates as 0, 0 in the distance formula. If you want to, you can try it. Moving on to section formula, let there be a point A with coordinates x, x1, y1, and let there be another point B with coordinates x2, y2, and join the line AB. At somewhere in the middle of AB, let there be a point C with unknown coordinates x, y. We don't know the coordinates of C, x, y. Now let C divide the line segment AB in the ratio m is to n. Let that also be known. The only unknown parameter be the coordinates of C, x, y. We know all the other parameters. So section formula is used to find the coordinates of that point C, which is dividing another line segment in some given ratio. So the equation is x is equal to mx2 plus nx1 by m plus n, and for y the equation is my2 plus ny1 by m plus n. I hope my point is clear. So section formula is used to find the coordinates of a point that divides the line joining another two points in some given ratio m is to n. Moving on to the next, midpoint formula. Midpoint formula is a special case of section formula itself. Remember we talked about the ratio m is to n? Well, in midpoint formula, C, the point C will be exactly in the middle of the line joining A and B. So the ratio m is to n will be 1 is to 1. Now then the coordinates of C can be found using the equation x is equal to x2 plus x1 by 2 and y is equal to y2 plus y1 by 2, where x1, y1 and x2, y2 are the coordinates of the other 2 points A and B. Now the next formula is to find area of a triangle. We have plenty of equations to find area of a triangle. Using coordinate geometry concept, we can find area of a triangle if we know the coordinates of the 3 vertices of the triangle. Let's take the case of the triangle shown in the figure, triangle PQR. As indicated, the coordinates of P is x1, y1, those of Q is x2, y2, and those of R is x3, y3. Now the equation for area of triangle PQR is given by half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Very long, isn't it? You can remember it this way. Half is outside, x terms are outside the bracket and y terms are being subtracted. Now have a look at the first 3 terms. After half, it comes 1, 2, 3, as in x1 into y2 minus y3. So 1, 2, 3. Now you can follow the same pattern for the other one. For the next term is 2, 3, 1, as in x2 into y3 minus y1. Now for the third, it's 3, 1, 2. That is x3 into y1 minus y2. So all you have to remember is x outside multiply to y minus y. Then remember these numbers. First 1, 2, 3 plus x into y minus y. So that will be 2, 3, 1 plus the other one will be 3, 1, 2. I hope you understand what I mean. So this way you can study the area by heart, the equation or the formula to find area of a triangle using coordinate geometry. Collinearity condition. Imagine 3 points are scattered on a plane. The polygon or the figure that we can draw by connecting all the 3 points is a triangle. Now what is the case when all the three points lie on a same line? Then such a triangle, there is no possibility of construction of a triangle. So that's the case when we can say the 3 points are collinear, lying on the same line. So the condition for collinearity is that the condition for collinearity of 3 points is that the area of triangle formed by those 3 points is equal to 0, which means that such a triangle doesn't exist. So we can equate that to the triangle formula, half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2 is equal to 0. Now, provided that we know the coordinates of these 3 points. So the coordinates will be x1, y1, x2, y2 and x3, y3, and the question will be asked to prove that these 3 points are collinear. So all you have to do is substitute these values, these coordinate values in the equation for area of a triangle and equate it to 0. And while substituting the equation for area of a triangle, you have to eliminate the half, because half when we take it to the other side, it will go. So you can simply write the equation for collinearity as x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2 equal to 0. The centroid of a triangle. What do you mean by centroid of a triangle? Centroid is the meeting point of all the 3 medians that we draw in a triangle. Centroid is a point, the meeting point of all the 3 medians that we draw in a triangle. So imagine we know the coordinates of all the 3 vertices of a triangle, x1, y1, x2, y2 and x3, y3. We can find the coordinates of the centroid using the equation x and y. So let x and y be the coordinates of the centroid G as in this figure. So x is equal to x1 plus x2 plus x3 by 3 and y is equal to y1 plus y2 plus y3 by 3. Simple, right? Okay, now we shall move to solving problems. The first type is very short answer type questions of 1 mark each. The first question, find the distance of the point -3, 4 from the x-axis. So we are supposed to find the distance from the given point from x-axis. So the simplest way is to try plotting this in a simple Cartesian plane. You can see in the figure shown in the extreme right, the point has been plotted and we have traced it to both the axes. Now, how far is it from the x-axis? How far is -3, 4 from the x-axis? How many divisions far is it from the x-axis? You can count it from the origin to the right side, to the left side. So there are 4 divisions because it is -3, 4. So the y coordinate will be the gap of the point from x-axis. You can note down that point, especially the gapping or the spacing of a point from the x-axis will be its y-coordinate, that is 4 units, and vice versa. Next question. If the points A of x2, B of -3, 4 and C 7, -5 are collinear, then find the value of x. So 3 points are given. One of the coordinates of the one point is x, it's unknown, and the condition is given that they are collinear. We are asked to find that unknown coordinate. So what is the equation for collinearity of 3 points? Area of triangle formed by the 3 points is equal to 0. So the equation x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2 is equal to 0. We can substitute the points x1 y1, x2 y2 and x3 y3 and equate it to 0, and upon solving we will get the value of x as -7. So the unknown coordinate is -7. Moving on to the next question. In which quadrant the point P that divides the line segment joining the points A of 2, -5 and B of 5, 2 in the ratio 2:3 lies? Now the question is simple, the idea of the question is simple, but they asked it a little twisted. So we are supposed to find the quadrant in which the point P is lying. Condition, the point P is dividing the line joining AB in the ratio 2:3. So when a point is sectioning a line in some ratio, which is a formula that we use? Exactly, section formula. So section formula, x is equal to mx2 plus nx1 by m plus n, and y is equal to my2 plus ny1 by m plus n. Now we can see that we have to find the coordinates of P first. So they have written it together. So P is equal to, in the single bracket they have written equation for x and equation for y. So we will get the coordinates of P as 16 by 5 and -11 by 5. So the x coordinate is positive and y coordinate is negative. Now in which quadrant is x coordinate positive and y coordinate negative? Fourth quadrant. So the answer for the question is fourth quadrant. Moving on to the next question. ABCD is a rectangle whose 3 vertices are B40, C43 and D03. Calculate length of one of its diagonals. So we don't have the fourth vertex, so we have to find the fourth vertex. To find that, now we can try plotting the rectangle in a Cartesian plane. You can see in the figure here. So we can observe that the fourth vertex A is 0, 0. The coordinate is 0, 0 or the origin. Now we can apply Pythagoras theorem in the rectangle. Before that we can find the side AB. How far is the point B from the y-axis? It's x coordinate. So AB is 4 units. And how far is the point C from the origin? We can use the equation root x square plus y square and we will get it as 3 units. BC is 3 units. Therefore, using Pythagoras theorem in triangle ABC, we can write AC square is equal to AB square plus BC square, and upon applying the values, we can find that AC square is equal to 25 or AC is equal to 5 centimeter. Now comes the next question. In the figure, calculate the area of triangle ABC in square units. So the figure has been given again, area of triangle ABC had been given in the figure. The coordinates are A 1 3, B -1 0 and C 4 3. Now we have to apply half BH or half into the equation using coordinate geometry. Because this is a 1 mark question, we can simply use the half BH equation. Now how far is the 2 points BC? That will be the base. Now how far is the 2 points from each other? You can see B is placed 1 division away from the origin and C is placed 4 divisions away from the origin. So the total is 1 here, 4 here. So 1 plus 4 is 5. So the base is 5 in this case. And how far is A from the x-axis? Again, the gap between a point from the x-axis will be its y-coordinate. So the y-coordinate of A is 3 here. So 3 is the height of the given triangle. Now half into 5 into 3 or half into 15. 15 by 2 is equal to 7.5 square units. They have specifically asked to express the area in square units. Moving on to the next question. If 3, 3, 6, y, x, 7 and 5, 6 are the vertices of a parallelogram taken in order, find the values of x and y. So we are given all the values, all the coordinates except 2 of the coordinates are unknown. Say they have expressed it in the form x, y. So construct a parallelogram and they have said it's taken in order, so you can assign those coordinates in order, and there is a property for parallelogram. In a parallelogram, the diagonals will bisect each other, which means that the midpoint of AC will be equal to midpoint of BD. So we can again apply midpoint theorem. X1 plus x2 by 2 and y1 plus y2 by 2 and equate it to either side. So that's what we had done. Midpoint of AC is given as 3 plus x by 2 and 3 plus 7 by 2. Those are the coordinates of midpoint of AC. Now for midpoint of BD, it's 5 plus 6 by 2 and 6 plus y by 2. Now we get two separate equations in terms of x and y. Now equating those, we will get the value of x as 8 and y as 4. So x is equal to 8 and y is equal to 4. Those are the unknown coordinates. Moving on to the next type of questions, short answer type questions carrying 2 marks each. Find a relation between x and y such that the point P of xy is equidistant from the points A and B. A is 2, 5 and B is negative 3, 7. Now equidistant means the distance from the point P to both A and B are the same. PA is equal to PB. That has been shown in the figure. You can directly apply distance formula. AP is equal to BP and we can square it. Why are we squaring it? According to distance formula, it is root x2 minus x1 whole square plus y2 minus y1 whole square. So if we equate two distances and square, the root will get cancelled then and there. That's why we had written AP is equal to BP, that's given, and in the next step we had squared it to eliminate the square root. So we will get the equation x minus 2 whole square plus y minus 5 whole square is equal to x minus 3 whole square plus y minus 7 whole square. No, we don't know x and y. The question is to find a relation between x and y, as in find an equation with x and y in it. So upon cancelling and picking up like terms and adding or subtracting, we will get the equation as negative 10x plus 4y is equal to 29. Now that's the relation connecting x and y. Moving on to the next question. Find the ratio in which P 3 by 4 and 5 by 12 divides the line segment joining the points A 1 by 2, 3 by 2 and B 2, negative 5. So we have to find the ratio in which P, the coordinates are given, and A coordinates are given, B coordinates are given. You can see the figure above. There is AB and P somewhere in the middle of AB. Now we are supposed to find the ratio. When the question is to find the ratio, we don't take the ratio as m is to n. Instead, we will take the ratio as k is to 1, where k is any variable. Why? We can take m is to n, but it will become very complex and will take a lot of steps, and it's too time consuming. To avoid that, to make it simpler, we have to take the unknown ratio as k is to 1. I hope my point is clear. So whenever the question is to find the ratio, assume the ratio as k is to 1, not m is to n. So let ratio is equal to k is to 1. Now instead of using m and n, you can put k and 1. So upon cancelling, we will get k is equal to 1 by 5. So we can write the ratio is 1 is to 5. The ratio in which P is dividing AB is 1 is to 5. You have to conclude it every time. Moving on to the next question. Find the ratio in which y-axis divides the line segment joining the points A of 5, negative 6 and B of negative 1, negative 4. Also find the coordinates of the point of division. A lot of unknown parameters here. The first part of the question is to find the ratio in which y-axis is dividing the line segment. So when we are asked to find the ratio of section, we have to assume the ratio as k is to 1. And the ratio in which y-axis divides the line segment. It's not just any point, it's y-axis that is dividing the line segment. So let's take that point as C, and any point in y-axis can be expressed in the general form 0, y. There will be no x coordinate for any point lying along the y-axis. So let C be the point in the middle as in between A and B, and let the coordinates of C be 0, y, and the ratio is taken as k1. Now we can apply section formula. So k minus k plus 5 by k plus 1 will be the x coordinate of C, and minus 4k minus 6 by k plus 1 will be the y coordinate of C. Now we know that the x coordinate of C is 0. So we can equate minus k plus 5 by k plus 1 as 0. Then the value for k is obtained as 5. K is equal to 5. So it's a ratio. So k is to 1 will be 5 is to 1. Let's keep it over there. Now we have to equate y is equal to minus 4k minus 6 by k plus 1, the second coordinate. Now that we know the value for k, we can substitute for k as 5 in all the remaining equations or all the steps, and we will get the coordinate, the required coordinate of the point C as 0 and negative 13 by 3. Yes, that's the coordinate of the point C, 0, negative 13 by 3. Moving on to the next question. Let P and Q be the points of trisection of the line segment joining the points A of 2, negative 2 and B, negative 7, 4, such that P is nearer to A. Find the coordinates of PQ. Now while solving section formula especially, you have to show the illustration. Draw the question first, then sort out the method. So let's begin. Let P and Q be the points of trisection. We know what is bisection, dividing into two equal parts. So trisection will be dividing into 3 equal parts. So there is a line AB and there are 2 points P and Q, so that AP is equal to PQ is equal to QB, trisection. So P and Q are trisecting the line joining AB such that P is closer to A. So A, P, Q, B. That is the order of the points in the line. We have to find the coordinates of both P and Q. Now let's consider only P is present. There is no Q. So what is the ratio if only P is present? There was A, P, Q, B. Now Q is not there. What will be the ratio? Into how many parts was AB trisected? 3 parts. So there are 3 parts, but now Q is not there. So AP will be 1 part and PB will be 2 parts out of the total. I hope you understand what I am saying. Since AB was being trisected, now we are eliminating or just hiding Q for time being. So now the ratio AP by PB will be 1:2. Now you may apply section formula mx2 plus nx1 by m plus n and my2 plus ny1 by m plus n. We can find the coordinates of P as -1, 0. Now let's take Q as well. Now we can take the line PB. We don't want A. Let's take the line PB. We know that all the lines are equal, so we can say that Q is the midpoint of PB. I hope my point is clear. So Q is the midpoint of PB, so we can apply midpoint formula to find Q. So apply midpoint formula, that will be x1 plus x2 by 2 and y1 plus y2 by 2 will be the coordinates. Using that equation, the coordinates of Q will be -4 and 2. Hence, we found coordinates of P and Q. Now comes the next question. Three vertices of a parallelogram taken in order are -1, 0, 3, 1 and 2, 2 respectively. Find the coordinates of the fourth vertex. So there are three coordinates. Now the fourth vertex, the coordinates of the fourth vertex is unknown. You have to do the property, you have to apply the property of diagonals of a parallelogram, that the diagonals of a parallelogram will always bisect each other. That means their midpoints will be the same. They will be meeting at the same point. So we can say that coordinates of midpoint of diagonal AC will be equal to coordinates of midpoint of diagonal BD. Now you can find the midpoint of AC using midpoint theorem. That is equal to, using midpoint theorem again, you can find or form the equation to find midpoint of BD. Equate both of them, we will get x as -2 and y as 1. So x is equal to -2, y is equal to 1 is the coordinate of the third or the fourth vertex of the parallelogram. Moving on to the next question. If the points A of 1, -2, B of 2, 3, C of -3, 2 and D -4, -3 are vertices of a parallelogram ABCD, then taking AB as base, find the height of this parallelogram. You can see the parallelogram given in the figure. ABCD, all the vertices are given. We have to find the height DM, taking AB as the base. So we know that area of a triangle is half BH, but we don't know exactly the value of the area of triangle DAB. So we can use equation for area of a triangle using coordinate geometry. So that's what we are doing in the first step. Area of triangle ABD is equal to half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Substituting all the values, we will get the area of triangle ABD as 12 square units. Now we can equate also area of triangle ABD is equal to half into B into H. Now we can find AB using distance formula. 2 minus 1 whole square plus 3 plus 2 whole square whole root. We will get root 1 plus 25 or root 26. So AB, that is a base, is 26. We know area, we are asked to find the height. So half into root 26 into DM is equal to 12. On cancellation and rationalizing the denominator, we will get the height DM as 12 by 13 root 26 units. We shall now discuss the next type of questions. Long answer type questions carrying 3 marks each. Now we shall begin. Find that values of x for which the distance between the points P of x, 4 and Q of 9, 10 is 10 units. So we are supposed to find the values of x for which PQ is 10 units. And x is one of the coordinates or the x coordinate of the point P. So we can directly use the distance formula. PQ is equal to 10 units And remember, we have to eliminate the square root. So we can write PQ square is equal to 10 square, that is equal to 100. Now we can equate it into the formula. So the equation will become x2 minus x1 the whole square plus y2 minus y1 the whole square is equal to 100. Putting the values of x and y, we will get two values for x, because 9 minus x square will be 64. So 9 minus x, on taking square root on both sides, we will get 9 minus x is equal to root 64, that is equal to plus or minus 8. So for two values of it, you will get two values of x, which are 1 and 17. So the possible values of x are 1 and 17. Moving on to the next question. If the point P of k minus 1 and 2 is equidistant from the points A of 3 comma k and B of k comma 5, find the values of A. So there are 2 points AB and another point P which is equidistant from AB. That means PA is equal to PB. Now all the 3 points A, B and P have K as one of their coordinates. So we can directly put PA is equal to PB and apply distance formula. Now squaring, we'll eliminate the root. So PA square is equal to PB square. On putting values, we will get the equation k square minus 6k plus 5 is equal to 0. Now that's a quadratic equation, so we have to solve by splitting the middle term. So we will get k is equal to 5 or k is equal to 1. Now here comes the third question. Find a point P on the y-axis which is equidistant from the points A 4, 8 and B negative 6, 6. Also find the distance AP. So again, it's equidistant concept. There is a point P on y-axis. So the coordinates of P would be 0, y. So P is equidistant from A and B. So we can directly put PA is equal to PB and squaring PA square is equal to PB square, and hence we can get the value or find the coordinates of P as 0, 2. As in y is equal to 2. That first part is done. Now we have to find the distance AP. So using distance formula, you can find AP as root 52. 52 is not a perfect root, so we can keep it as it is. So root 52 units is the distance AP. Moving on to the next question. Prove that the points A 0, negative 1, B negative 2, 3, C 6, 7 and D 8, 3 are the vertices of a rectangle ABCD. So what are the properties of a rectangle? In a rectangle, the opposite sides are equal. So AB will be equal to CD and AD will be equal to BC. Also the diagonals will be of equal measurements. So AC will be equal to BD. So we have to find all the sides AB, BC, CD and AD. So we can get BC is equal to AD is equal to 4 root 5 using distance formula. Using the same equation, we can get the other two opposite sides as 2 root 5. So they are also equal and the diagonals will be equal to 10 units each. So opposite sides are equal as well as the diagonals are equal. Therefore, ABCD is a rectangle. Show that the points negative 2, 3, 8, 3 and 6, 7 are the vertices of a right triangle. What is the property of a right triangle? In terms of its sides, we are dealing with sides in this chapter. So in a right triangle, we can apply Pythagoras theorem, which states that the square of hypotenuse is equal to sum of squares of the other two sides. So we have to find AB BC and AC. You can directly find AB square, AC square and BC square, and we will get AB square as 100, BC square as 20 and AC square as 80. So 100 is equal to 20 plus 80. So we can write BC square plus AC square is equal to AB square, which means that the sides of this triangle is satisfying Pythagoras theorem. Therefore, by converse of Pythagoras theorem, we can conclude that this given points will form a right triangle. Moving on to the next question. The coordinates of a point P is twice its y coordinate. If P is equidistant from Q of 2, -5 and R, -3, 6, find the coordinates of P. So again, P is equidistant from 2 points Q and R and the coordinates are given. And now there is a relation between coordinates of P itself. The x coordinate of the point P is twice its y coordinate. So let's take the x coordinate of P as, the y coordinate of P as k. So the x coordinate will be twice of that. That means if y coordinate is k, x coordinate will be 2k. Again, using PQ is equal to PR, equidistant. So you can square it. PQ square is equal to PR square. Applying distance formula, we can find the value of K as 8. Now, K is 8. That is the Y coordinate. And how do you find the X coordinate? By doubling it. So, 8 is the Y coordinate. Double of it, that is 16, is the X coordinate. Therefore, the coordinates of point P are 16, 8. Moving on to the next type of question, very long answer type questions carrying 4 or 5 marks depending on the curriculum. We'll start with the first question. Prove that the points A 2, -1, B 3, 4, C -2, 3 and D -3, -2 are vertices of a rhombus ABCD. Is ABCD a square? That's the second part. That's the second question. So we are given 4 points ABCD. We have to check or prove that these 4 points are vertices of a rhombus. Now, what is the property of a rhombus? All the sides will be equal. That's right. So we have to find AB, BC, CD and AD, and using distance formula we got all the sides as root 26 units, which means that all the sides are equal. So now we have to check if ABCD is a square. Now ABCD is either a rhombus or a square. Now we have to confirm if this is a rhombus or a square. For that, we have to apply the property. We have to check the property of the diagonals. So using distance formula again, we are going to find the distance or the length of diagonal AC and the diagonal BD. So we got the length of diagonal AC as 4 root 2 units and that of diagonal BD are 6 root 2 units. So when the sides, all the 4 sides are equal, it's either a rhombus or a square. Now that the diagonals are unequal, we can confirm that ABCD is not a square. In a square, all the sides are equal as well as the diagonals are equal to one another. But in this case, one diagonal is 4 root 2 units and the other diagonal is 6 root 2 units. So they are unequal. So we can fully confirm that ABCD is not a square, but it's definitely a rhombus. Now comes the next question. If the points A -1, -4, B small letter b, C and C 5, -1 are collinear and 2b plus C is equal to 4, find the values of P, B and C. Now this is a frequently asked question. Only the values will change. The concept or the idea is the same. So pay attention. Now we are given that the points A, B, C are collinear, though that condition is being given. Now when they are collinear, we know that the area of the triangle formed by those 3 points is 0. So we can directly equate it to 0 and we'll get a relation between B and C that B is equal to 7 plus 2C. Now, we already are given in the question that 2B plus C is equal to 4. So, there are two equations. B is equal to 7 plus 2C and 2B plus C is equal to 4. Now, those are linear equations in two variables. Revise back to chapter number 3. We can use substitution method here. We can put the value of B as 7 plus 2C in the equation 2B plus C is equal to 4. On solving it, we will get the value of B as 3 and the value of C as negative 2. So, the answer to the question, B is equal to 3 and C is equal to negative 2. Here comes the next question. Find the values of K for which the points A of K plus 1, 2K, B of 3K, 2K plus 3 and C of 5K minus 1, 5K are collinear. Recollect the concept for collinearity. When 3 points are collinear, the area of triangle formed by those 3 points is equal to 0. So, equating that area of triangle is equal to 0, we will get the quadratic equation 6k square minus 15k plus 6 is equal to 0. Taking 3 as a common term out of all the 3 terms in the equation, we will get another simplified quadratic equation 2k square minus 5k plus 2 is equal to 0. Now, solving that using any method, you have already studied quadratic equations. So, solving that, we will get the values for k as 2 and 1 by 2. Here comes the next question. Find the area of the triangle formed by joining the midpoints of the sides of the triangle whose vertices are A 2, 1, B 4, 3 and C 2, 5. So, there is a triangle formed by 3 given points A, B, C and all the coordinates had been given for A, B, C. We have to find the area of the triangle formed by joining midpoints of these sides. So, we have to mark the midpoint of AB as D, then midpoint of BC as F and that of AC as E. Now, using midpoint theorem, we can find the coordinates of D, E and F using midpoint theorem. What was midpoint theorem? x1 plus x2 by 2, comma, y1 plus y2 by 2. Using midpoint theorem, we got the coordinates of D as 3, 2, E as 2, 3 and F as 3, 4. Now, now that we have the coordinates of vertices of the smaller triangle DEF, we can find using the equation for area of a triangle, that is half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. So, that substituting all the coordinates in that equation, we will get the area of the small triangle as 1 square units. Moving on to the next question. If the area of triangle ABC formed by A of xy, B of 1, 2 and C of 2, 1 is 6 square units, then prove that x plus y is equal to 15 or x plus y is equal to 9. So, again the vertices are given, but for the first vertex A, the coordinates are in the form x, y, but that's okay. What we have to prove is that we are given the area of the triangle, we have to prove a relation connecting x and y. So, let it be x and y itself. So, area of triangle is 6 square units. So, the equation is equal to 6. Now, putting on the values, we will get an equation x plus 1 minus y plus 2y minus 4 is equal to plus or minus 12, or x plus y. So, there are two possible values for 12, plus or minus. Now, if we take x plus y for plus 12, we will get x plus y is equal to 15. And if we take x plus y for negative 12, we will get x plus y is equal to 9. Sorry, negative 9. Moving on to the last question. In the given figure, the vertices of triangle ABC are A of 4, 6, B of 1, 5, C and C of 7, 2. A line segment DE is drawn to intersect the sides AB and AC at D and E respectively, such that AD by AB is equal to AE by AC is equal to 1 by 3. Calculate area of triangle ADE and compare it with area of triangle ABC. It's a very long question and we have to integrate the topic that we had studied in the chapter triangles as well. So, given that AD is to AB is equal to 1 by 3. So, from that we can extract that AD is to AB. In the question it was given AD by the whole is 1 by 3. So, now we can write it in ratio form part by part. So, AD by DB will be equal to 1:2. Similarly, AE by EC will be equal to 1:2. Now that we know the M is to N ratio in which D and E has divided the respective lines, we can use section formula to find the coordinates of D and E. I hope my point is clear. Now we know that the ratio of sectioning of both sides AB and AC is 1:2. We can apply section formula to find the coordinates of D and E. So applying section formula, we got the coordinates of D as 3, 17 by 3 and the coordinates of E as 5, 14 by 3. Now that we know all the coordinates of the triangle ADE, we can find it using the equation to find area of a triangle and we will get the area as 5 by 6 square units. Area of triangle ADE is equal to 5 by 6 square units. Now we already know the coordinates of ABC, so we can find area of triangle ABC using the same equation and we will get the area of triangle ABC as 15 by 2 square units. 15 by 2. Now the question is to calculate area of ADE, triangle ADE. We had done that and compare it with the area of triangle ABC. By compare, they mean we have to take the ratio. So taking the ratio, area of triangle ADE, the small triangle versus the big triangle, that is ADE by area of triangle ABC, we will get 5 by 6 by 15 by 2 or equivalently 1:9. Thank you.